So now we're going to move on to 4.2, and we're going to do some basic matrix computation. Now that we know how to identify the dimensions of matrices and kind of figure out the elements and what they look like, now we're going to move on and do some basic arithmetic. So for today, how to use basic arithmetic with matrices. The two big ones we're going to cover, we're going to do add, we're going to do subtraction, and then we're also going to do something called scalar multiplication. Hopefully it's not really that bad. So how do you add two matrices together? Matrix addition. So if you have two matrices, A and B, we call them just capital A and capital B, as long as they have the same dimensions, which you should know what that means by now, their sums, A plus B, is the matrix in which each element, you guys know what elements are now, is the sum of the corresponding elements in A and B, which just means that we have to match up the right row and column, add those two numbers together, and we put it in the next row and column, the same one. That's what this means. So we're going to add the same elements in the two matrices. That's why they have to have the same dimensions, otherwise they won't match up. So as an example, for example 1, let A equal A, B, C, D as a matrix, and B is E, F, G, H. We're going to find A plus B. So whenever it does this, that means, A and B equals these matrices. We're going to just substitute A and B in here and add them together. So in this particular case, we don't have any numbers, but we can add them without numbers because it doesn't matter. So we're going to do A plus B, which means, I'm just going to put a little equal sign here. This means we're going to do A, B, C, D plus E, F, G, H. So how do we do that? We're just going to look at the same row, same column, and add them together, right? So if we do 1, 2, 1, 2, 1, 2, 1, 2, as long as they're both the same dimensions, which they are, they're both 2 by 2s, then we can add them together. So how do we do that? We're going to do a big matrix. So the first row and first column is A. What does that one get added with? We just do one at a time. A plus the one that's also in the first row, first column is E. So A plus E. Now, when these are numbers, we will add them together. So that would be your first one. Also, this is going to be the same output. It's going to be a 2 by 2. So I'm going to do 1, 2, and then a 1, 2. I'm just going to put little blanks here. Maybe that'll be helpful. So we move to the next one. I'm going to do actually different colors here. So we have first row, second column would be B. That gets added with what? F. B plus F. Keep going. Second row, first column is C. Same thing in the second matrix would be G. So C plus G. And the last one is D plus H. And so the output that we get when we add them together is also another 2 by 2 matrix. So the dimensions don't change, and they have to be the same from the beginning. Otherwise, you cannot add them together. Not possible if that's the case. So make sure you look and see if they're the same dimensions, and then you can add them together. So let's try some. Add the following matrices if possible. So what do we have here? We have a 1, 2, 1, 2, 3. This would be a 2 by 3. Same thing here. 2 by 3. So we're good. Let's add them together. We're going to get out a 2 by 3. So 1, 2, 3, 1, 2, 3. I'm just going to put the blanks in there. So we do 1 plus 2 is 3. 5 plus 6 is 11. 9 plus 3 is 12. Go down the bottom. 2 plus 4 is 6. 7 plus 3 is 10. Just a bunch of addition. 2 plus 1 is 3. All right, the second one. This one should prove to be a little problematic because if you look at it, we have a 1 row, 2 column. This is a 1 by 2. And then look what this one is. Clearly not the same thing. This is going to be a 2 by 1. And since they're not the same, there is no answer. I'm just going to write no solution. There's no answer. No matrix could be added together like that because they don't have the same dimensions. All right, then part C. Looks like we have a 3 by 3 adding to another 3 by 3, so we should be good. And it's going to output a 3 by 3. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3. And make sure you draw those brackets a little better than I did. We did 2 plus 0 is 2. You guys can go through this and add them all together, although be careful since now we have some negatives. We have 1 plus negative 1, that's a 0. 3 plus 9, that is 12. Going through the second row, negative 1 plus 1, 0 again. Negative 3 plus negative 1, careful with that, negative 4. Negative 1 plus 5 is 4. Last row, 2 plus negative 4 is negative 2. Negative 3 plus 4 is 1. And the last one, 1 plus 3 is 4. Just basic arithmetic, just adding. In that particular case, we added 9 different times to get the last matrix, the final matrix, which is also a 3 by 3. So you can always set them up that way and just draw the blanks. And then add each one individually, all the corresponding elements. Okay, moving on to subtraction. This is literally no different. You have to have the same dimensions. Their difference is A minus B, is a matrix which each element is the difference of the corresponding elements. Just subtract the two that are in line. So I'm going to quickly go through this one, starting with matrix A and B with just a bunch of letters here. Find A minus B. So that would mean we're going to do A, B, C, D minus E, F, G, H. So if you know how to add and subtract, for the most part, you'll be pretty good with this lesson. So what is this going to be? Remember, we have to do the same corresponding elements. So we're going to do A minus E would be the first one. We're also going to get another 2 by 2. So it's 1, 2, 3, 4. Go a little faster through this. We have B minus F, C minus G, and D minus H. The only thing you have to be careful with subtraction is that you might have negative numbers already in here, so you may have to change them to positives. You know, some of the ones with the E, F, G, H. If you have a minus sign in front of it, it might change to positive if they're already negative. So let's try some of these. Subtract the following matrices if possible. So let's see. Can we subtract these two? This is a 3 by 2. This is also a 3 by 2. As long as they look the same dimensions, we're good. And it's going to be a 3 by 2 out. So 1, 2, 1, 2, 1, 2. So let's subtract. 1 minus 2, that is negative 1. Negative 1 minus 3 is negative 4. 2 minus 8, negative 6. And we keep going. 4 minus a negative 2. This is the first time we see this double negative here. That's going to be changed to a plus, so it's 4 plus 2, which is 6. 6 minus 4 is 2, and then 8 minus 2 is 6. That's it. Another 3 by 2. All right, part B. Do they match up? Same dimensions. We have a 3 by 3 and another 3 by 3. Okay, so we're going to get out a 3 by 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. Perfect. 2 minus 0 is 2. 1 minus negative 1, which turns to a plus 1, right? So 1 plus 1 is 2. 3 minus 9, negative 6. Negative 1 minus 1, negative 2. Negative 3 minus a negative 1. Oh, turns to a plus here. So that's negative 3 plus 1, which is negative 2. Just be careful with those. Negative 1 minus 5, negative 6. 2 minus a negative 4, another plus. So it's 2 plus 4, 6. Negative 3 minus 4 is negative 7. 1 minus 3, negative 2. So as long as you're good with adding, subtracting with negative numbers, should be easy, easy as pie. And the last one, part C, if you look at this, clearly we have an issue here. We have a 1 by 2, and we also have a 1 by 3. They are not the same. Not the same. So therefore, we're going to say there's no solution here. right? Because if we tried to do it, you might, do 1 minus 3 and 2 minus 1, but now there's one number left over that you can't put together with anything. So we're not going to do it that way. We're done with that. No solution. Which is nice. No work to be done. Or we have two more, but this is really just substituting it in and adding it. So I guess I'll go through this one quickly, and then we have one more thing to go over. Maybe two more things to go over, and then we'll be done. So let's go ahead and just substitute these in. A plus B means you're going to replace A with the matrix A. Same thing with B. So I'm just going to rewrite it, changing out A and B here. So it goes 1, 3, 5, -2, plus -3, 1, 8, 4. Add them together. So it's 1 plus, I should set it up, I guess. They are both 2 by 2s, so we'll get another 2 by 2. 1 plus a -3, -2. 3 plus 1, 4. 5 plus 8, 13. -2 plus 4 is 2. All right, same thing with A minus B. Copy them down. 1, 3, 5, -2, minus -3, 1, 8, 4. Another 2 by 2. That's not too good. Let's change it up. 1, 2, 3, 4. All right, 1 minus a -3 turns to a plus, so that's 4. 3 minus 1 is 2. 5 minus 8, -3. -2 minus 4. That's a 4, right? Yeah, -6. And if I went too faster there, make sure you go through and double check and make sure you can do it yourself. My brackets are getting kind of ugly here, which again ends up being 2 by 2 as your output. Or really the last thing we're going to go over, almost the last thing I guess, is multiplication. Now we're not multiplying two matrices together because that ends up being a little bit more complicated. We'll get to that later in the next lesson. Right now we're just going to be doing something called scalar multiplication, which means we're just going to be multiplying it by a number on the outside. So the scalar product of a real number, k, they're saying that k is the numbers on the outside. If we multiply k times a matrix A, or they call it k times A, Ka, in which each element is k times the corresponding element in A. So really what's happening here is it's just like the distributive property. So let me show you. So if A is A, B, C, D, and k is any real number, then what happens? If we do k times A, or Ka, then we're going to do k times the matrix A. So I'm just going to put that down here. A, B, C, D. So what do I mean by the distributive property? If you have a number outside of a matrix, the k goes to everything, the A, the B, the C, the D. So as a final answer, it stays the same, stays as a 2 by 2, just like it always has been. So we would do k times A, Ka, k times B, k times C, and k times D. So they all get multiplied by whatever's on the outside. And that's it. And then we can also do some problems where we combine these, where you combine multiplying a number on the outside with addition and subtraction. So let's try some where we're just going to multiply it through. Find the scalar multiplication of each matrix. So I'm multiplying everything by 5 here. It is still going to be a 2 by 3. So let's do that. 1, 2, 3. 1, 2, 3. Multiply everything by 5. So we have 10. We have 5. -10. We have a -25. Right? It's going to everything. Boom, 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 boom. There we go. 5 times 8, 40. 5 times 6. Oh, it's a -6. So -30. All right. You guys can finish the other two. Multiply by a -2. And the last one, you're going to multiply by a -5. So I'm just going to go ahead and fill them in. Make sure you get the same thing. 1, 2, 3. 1, 2, 3. 1, 2, 3. -20, -5. Really just practicing multiplication right here. 45, 0, -20 again, -10, -15. And it's possible I might get one of these wrong. I'm going fairly quickly through it. That's a -55. And that's it. We have one example left, then we're done. So we're going to actually throw some variables in here and try to solve for them. Some of them aren't too bad. Then it gets a little bit more complicated a little later. A is not bad. B is a little bit more complicated. So let's look at part A. You see we have two matrices being added together, and then we also have the answer, what it equals. So we're going to go through and see if we can find the answers for A, B, C, and D. Okay. So maybe you can even look at it, right? So if you're looking at the corresponding elements, A would match up with what number? That would be 17. So we could say something plus 17 equals, what's that correspond with in this one here? That would be 21. So we could say something plus 17 equals 21. You might be able to do that in your head. If not, you could write it out as an actual equation. A plus 17 equals 21. And hopefully you know that A would be, if you subtract 17 on both sides, 4. So A is 4. You can go through and do the rest as well. So the next one we would do, B, that matches up with, first row, second column, 18 and 81. So we would say 18 plus B, some number, equals 81. So go ahead and figure out what that one is. $63. Minus 18 on both sides. Same thing, go through and do C, change colors again. C matches up with 25 and 54. So now we're saying 54 plus C equals 25. Oh, looks like this is going to be a negative number, right? If you solve this out. So what would that be? Looks like it will be a negative 29. And then the last one we do as well, D, 35 and 30. 35 plus D equals 30. And clearly that should be, if you look at it, would be negative 5 to drop it down to 30. Okay, and we have one last one. It's a little bit more complicated because we have some numbers on the outside. You can see the 2 and the negative 7 here. But what I would do is set it up how we've been doing with these equations over here. I'm going to do the same thing. So we're going to try to find A first. So A matches with 3 and 1. So watch how I do this then. If we have a 2 on the outside, remember you would distribute the 2 to the A. So we could say it's 2A, 2 times A. Then go over a little bit more. The negative 7 goes to the 3. So minus 7 times 3. And then it equals 1. So then we just solve this for A. 2A minus 21 equals 1. We'll add 21 to both sides. 2A equals 22. If we divide by 2, looks like we'll get 11. And you're going to do the same thing, repeat it for B, C, and D. Let's go through those quickly, and then that will be it. B matches up with negative 1 and 0. Okay, so we have 2 times B. Don't forget the 2 on the outside. Negative 7 has to be multiplied by the negative 1, so minus 7 times negative 1 equals 0. 2B equals, back it up 1 second. 2B plus 7 equals 0. Minus 7 on both sides. 0 minus 7 is negative 7. Divide by 2. So unfortunately, this is going to be a decimal. You can either leave it like this or make it negative 3.5. And that's B. That's okay. You can have decimals. All right, we'll erase this. We'll do C and D and be done. All right. C matches up with 14 and 4. So 2 times 14 minus 7, 7 times c, right, equals 4. Then solve for c. So 28 minus 7c equals 4, minus 28 on both sides. So negative 7c equals negative 24, divided by negative 7. Oh, no, it's another decimal. I'm going to leave it as a fraction, negative 24 over 7. That one's really ugly. That would be like 3 point something. Maybe almost close to 3.4, 3.5. And the last one, so again, you can get decimals. It's okay. Last one, we're looking at D. So I just circle where D is and then match up all the other two. We have negative 2 here and 4. Okay, so 2 times 4. I'm going to write it up here. 2 times 4. And then negative 7 times negative 2 times negative 2 equals D. Well, that's nice because D is already by itself. So we just have to figure out what this is on the left-hand side. So this would be 8. Negative 7 times negative 2 is a positive 14. So final answer would be 22. Right? That should work. So that one was actually fairly long, but I would also say probably the most complicated one out of all the ones that we've done is part B to answer all those equations. Definitely make sure you know how to do these ones because they're a little easier and a little bit more applied than just multiplying and adding, subtracting. And so that will be the end of 4.2, and then you can do the rest of the huddle problems. Oh, we're solving for x and y here. But it's just basic addition. That's not too bad. And then the next lesson will be actually multiplying two matrices together. That will be 4.3.